17 because I didn't do a very good job of answering it last time. First of all, if we have x equals 2y squared plus 3, and it intersects the line at that point, then we can solve for s, right? In other words, we have to be able to substitute either of these points into this equation. So that should have been our first step immediately, is to solve for s and solve for d. So I can solve for s by substituting 5 for x and s for y. And then if we do the math, we get s squared equals 1. So what's s equal to?
1.
No, plus or minus 1.
Oh, plus or minus.
That's important. Always remember that whenever you're solving an equation by taking the square root of both sides, start your answer out with plus or minus. That's what I try to tell everybody, because 95% of my students forget the plus or minus. And it will cost you on both exams in your class and the SAT test. You need to know that plus or minus. Okay? So now if we go to solve for D, what do we get?
You get...
Let's just substitute. So what equation do I get?
X is equal, no, yeah.
Plug in this coordinate. In other words, if it intersects this line at these two coordinates, then at those two coordinates it has to be equal to that equation. So that's the most important concept to get here, is that if it intersects this curved line with this straight line, then I can plug these coordinates into this equation and solve for s, like I just did, or d. So what equation would result from plugging this into that function?
11 is equal to 2d squared plus 3.
Which makes d equal to what?
Wait, so you'd subtract 3 first.
Right.
You 8. 4 squared 2.
Okay. Plus or minus 2.
Yeah.
And that's key in this problem, because they say, what is the greatest possible slope? Well, let's look at these lines here. If we have this line L and we're looking for a big slope, what's the measurement of that slope? It's the rise over the run. Well, the rise is the difference in the y coordinates, d minus s. The run is the difference in the x coordinates, 11 minus 5, or 6. So the greatest possible, since that's the slope, the greatest possible slope is where that is as big as it can possibly be. In other words, we want d minus s to be as big as it can be. Well, s is plus or minus 1. D is plus or minus 2. How do you make d minus s be as big as it can be? You make d be plus 2, and you make s be minus 1. And that gives you the maximum numerator you can have, which is 3 over 6. So the maximum slope you can have is 1/2. Okay? And this is a really good problem. And this is exactly the way you need to try to solve it. Okay, 18 is fairly tough also. Let's look at 18. Go ahead and read it.
Okay.
What's the master equation that governs this type of problem?
Distance equals rate times time.
Dirt is the way I remember that. Dirt. Okay? In other words, if you remember dirt, you can't ever get it wrong. All right, now let's try to define both of these, or every sentence in this question, in terms of dirt. So, she drove to the circus at an average speed of 30 miles an hour.
Okay.
So the distance equals 30 times whatever time it took her to get to the circus. We'll call it t sub 1. She returned home along the same route, meaning the distance was the same, so I can use the same variable d, only she went 25 miles an hour times a new time. Obviously, if she's going less speed, it's going to take a different time. You with me?
Mm-hmm.
Now what should we do? There's one more sentence. If her total travel time was 2 hours and 12 minutes, how many miles did she drive on her return? So they're asking us to solve for D.
Uh-huh.
Okay. But
Okay.
this sentence gives us another equation. If her total travel time was 2 hours and 12 minutes, how can I write that as an equation?
You could do D divided by 30? No.
This is her travel time to get to the circus?
T1 plus T2 equals...
T1 plus T2 equals... let's leave everything. So far, everything in the problem is hours. So let's leave it as hours. 12 divided by 60 is 1/5, so that's 2.2 hours. Okay, I've got two variables here I'm trying to solve for. If I can solve for T1 and T2, then I can solve for D. So what's another equation that I can now write regarding T1 and T2? Remember, this D is the same.
Yeah.
This is the distance to the circus. That's the distance from the circus back to her house. Has to be the same D. So what can I say about that and that? They have to be equal.
Are they still added together? Yeah,
They are equal. In other words, if D equals 30 T sub 1 and D, the same D, equals 25 T sub 2, then 30 T sub 1 equals 25 T sub 2. Now I have the classic two equations and two unknowns. How do I solve for T1 and T2? You got substitution, you got elimination.
I guess elimination.
Elimination, I always think of it, it works best when you have T1 and T2 on the same side. One moment here. Yeah. If you have one variable fully defined, then I think substitution works better. Well, in this case, we have kind of a combination. In other words, we have T1 over on the left side, T2 on the right, so I could easily solve for T1. T1 equals 25 over 30, T2. And now, if this was my information, I'd be more likely to incline to solve this by substitution. Okay? Because wherever I see T1, I can substitute that. So let's go back to that equation. That's the same as 5/6. So 5/6 T2 plus another T2 equals 2.2 hours. Now we've got it down to one equation, one unknown. What's the best way to solve it from here? How do you solve this equation?
Multiply it by 6 and divide it by 5.
I like that solution. What's the next line I should write?
5t squared, or yeah, 5t2, sorry, plus 6t2 equals whatever that is. So it would be like, yeah, all over 5. Right? All over.
No. No, the reason you multiplied both sides of the equation by 6 was to get rid of the denominator.
And now you have to divide it by...
No, you don't have to divide it by anything.
Really?
Not yet. You got to combine the t sub 2's. What's 5t sub 2 plus 6t sub 2?
11.
So we got 11t sub 2 equals 13.2. Now you divide by the coefficient. So t sub 2 equals 13.2 divided by 11. But they want how many miles she drove. So they want the distance. Well, we go back up to this equation right here. We got the distance is equal to 25 times t sub 2. So the distance she drove on her return, in other words, we want just the distance from the circus to her house, is equal to 25 times 13.2 divided by 11. Whatever that number comes out to be is what the answer you want to put in the book. And that actually ends up being a distance of 30 miles. Oddly enough, that simplifies to 30. Much as it doesn't look like it would. But.
Right.
Okay.
Cool.
All right. That is a classic distance, rate, time problem, and as hard as you're going to get. In other words, you're not going to see any harder than this on the test. And this is the classic solution also. So remember this problem. You're going to see this problem again. It may be slightly varied, but most likely it'll be almost the same as this. All right. Well, what do you think, Sarah? Should we start at 1 or should we start at like 20 or 30 on these things?
They get harder as you go further, right?
They do. Absolutely. At least these ones do. The Kaplan-based ones get harder as you go further. I'm inclined to think we're going to just waste your time by doing these problems.
All right, so let's start further on, I guess.
Yeah, let's go a little deeper here. 310. Let's see. If I go up to... Wow. We'll start right here. I just realized I only have test 4 and then I have test 9. Oh no, I have the other ones. They're just out of order on my sheet. Okay. We'll start here. 313. Number 13.
Okay, so
let's set it up. What's the equation I want to write?
okay, so you have m plus 3m plus 2m plus 3
Good.
in parentheses.
Don't need any parentheses because all my signs are plus. If I had a minus in there, I would need to use parentheses. Okay? What's the mean of that?
However many that is. Okay. So you'd get 6m plus 3.
Good.
And then you'd have to divide that by m. No, because you don't know how many you have.
Well, yes you do. You have to divide it by the number of days.
Oh, so with 3, so 2m plus 1.
That's it.
Why the number of days?
Well, because you've taken problems on 3 separate days, Monday, Tuesday, and Wednesday. And you're trying to find out the arithmetic mean over those 3 days.
Okay.
So you divide by 3. The arithmetic mean is always the total done divided by the number of days or the number of tests taken or so forth and so on. So this is a bit of a tricky one. Not tricky, but strange looking. Whoops, that's minus 1/2, incidentally. Oh, in fact, it's minus 1/2 on both sides.
So, I don't know, it can't be...
If we look at our answers, we see that 4 of the answers have a plus b in them.
Yeah.
So let's just solve this equation for a plus b. What would the first step in solving this equation be?
I guess to get rid of that negative 1/2.
Well, get rid of denominators. When you're solving equations, you want to get rid of denominators. What do I have to do to get rid of the denominator on the left?
Multiply it by a plus b.
To the what?
Negative terms.
To the negative 1/2, exactly. In other words, I want to multiply it by a plus b to the negative 1/2. That'll cancel with that. Which means I have to multiply this by a plus b to the negative 1/2. Now, what's the left side equal to?
The whole thing squared. Just a plus b to the negative 1/2.
Those cancel completely.
Oh, the left side, sorry.
That's okay. Now what about the right side?
Working on that. So it'd be a plus b, but since you square it, that would go to the negative first?
Yes. You add the exponents. Okay? So that's where we're at, which means 1 is equal to 1 over a plus b, which means a plus b equals 1.
So then it would be D.
Yeah, D.
Mm-hmm.
Yeah. Okay. Yeah, these SAT problems get harder quicker. When you're doing ACT, they don't tend to get hard until you get to about problem number 30. But these are plenty difficult.
Okay. So can you just substitute it in for y? Because you know that if CD is 4, then there's a point on both of them where it equals, or y equals 4.
So what's the first thing I can write?
Wait.
What's the first thing that has to be true?
That there's a point on both of them that they intersect at that
Is this
point?
y the same as this y?
Yes.
Well, it's not really. But it is at these points. In other words,
yes.
This equation applies to this one that points downwards. This equation applies to the one that points upwards. Well, there's only two spots where they're equal, at C and at D. So at these 2 points, I can say x squared plus 2 equals minus x squared plus a. At points C and D, that has to be true. Well, what does that allow me to do? If I solve this equation, what do I get?
So 2x squared plus 2 plus a.
Well, let's just do it all at once.
Minus.
Now, if the length of CD is equal to 4, what's the x-coordinate on D?
X-coordinate, well, you don't know.
Actually, you do. If you know that's equal to 4, we can see it's symmetrical about the y-axis.
True.
Yeah, so that has to be plus 2, that has to be minus 2.
Mm-hmm. So then the value of
So x is 2 or minus 2. So if I substitute plus 2 in for x, I can solve for a. That's 8 plus 2, a equals 10. I could have also substituted minus 2, because I can see that the x-coordinate at that point is minus 2. So since I'm wanting to solve for a, I know that when y is equal to y, we're either at point C or at point D. So I can substitute the x-coordinate that I know it has to be. That's a bit of a tricky problem also. That's a difficult problem, I would say.
Yeah.
A relatively high degree of difficulty. Well, let's see if we can do one more here. Oh, gosh. It's definitely hard.
Okay.
Have you done Venn diagrams?
No.
You haven't?
Well, not in math. Ever, I don't think.
This is set x. This is set y. Set x, which includes the shaded part, and they're telling us that that is b. Right?
Yeah.
In other words, if they have exactly b members in common, then there has to be b. That's the only common areas, right, where I've drawn it. So what would be left? In other words, if x has x plus 2b, how much is this right here?
That's going to be x plus 2.
X plus b.
Okay.
Right? now the total members in that set is x plus b plus b. Is
Yeah,
x plus 2b. So how many is in y?
And y plus 2b.
So now how many elements are in the union of x and y but not in the intersection of x and y? What's that going to be?
I don't know.
Well, they're asking for this area plus this area.
So x plus y.
Hold on.
Plus
X plus what?
Plus y.
There was a b there.
Oh, x plus b plus y plus 2b.
There you go. X plus b plus y plus 2b, which is which answer?
That's going to be b.
Yeah. And that's basically a Venn diagram. Now, Venn diagrams can come in lots of different flavors. This is the simplest you'll ever see, where you have two sets with a union, an intersection, a commonality. You know, you have so many people taking French, you have so many people taking Spanish, and you have a certain amount of people taking French and Spanish. Okay? Now, Venn diagrams can also come in other flavors. In other words, you can have a box around them. So if I have a box around them, then I got people taking Spanish or French, people taking Spanish, and people taking neither. So if you have three categories, sometimes you have to do your Venn diagram like this. The difficult part of the Venn diagram is defining these areas right here. Okay? That's a good one to stop on. That's a tough one there. But you're going to see problems like this on there. So, okay. Sarah, I will talk to you next Tuesday at 6:30.
All right, thank you.
Bye-bye.